Greeting learners. So we're gonna start a new session. This time around, we are taking paper 1 and paper 2 2024. We're going to start with paper 1. Here are the questions. Question 1. 1, solve for x. X times x minus 3 is equal to 0. We're going to remove the bracket by multiplying. X times x is going to be x squared minus 3x is equal to 0. You can do this by removing the bracket, or you can just simply say x is equal to 0, or x minus 3 is equal to 0. X will be equal to 3. So here we have got two roots, x is equal to 0, and or x is equal to 3. The next question is 112. Solve for x. 2x squared plus 1 is equal to 4x. We're going to transpose 4x in the left-hand side, so it will be 2x squared minus 4x plus 1 is equal to 0. Here we are having a quadratic equation. We're going to use the quadratic formula. You're normally having the formula at the end of your paper 1. You're just going to check the formula. Going to write them down. X is equal to minus b plus minus square root over b squared minus 4ac over 2a. So we are just applying this formula. Our x will be equal to minus b. Our b is minus 4, so it's going to be minus 4 plus minus square root over b squared is going to be minus 4 squared minus 4. The value of a is 2, and the value of c is 1 over 2a, 2 times 2. And here you're just going to take the calculator. So let's write down here, it's going to be 4 plus minus square root over 16 minus 8 over 4. So I'm going to continue here. X will be equal to 4 plus minus square root of 8 over 4. So we'll be having two values. So I'm going to use the calculator. They say here we must have our answers correct to 2 decimal places. 4 plus, we're going to start with plus square root of 8 over 4, and this will be equal to 2 plus square root of 2 over 2. With 1 decimal places is going to be 1,7. The first root, like this. The first one is 1,7, and we're going to take the next one with minus 4 minus square root of 8 over 4. Then we're getting 0,29. The first one with 2 decimal places is going to be 1,71, and the second one is going to be 0,29. So I think we have solved this first question. Question is saying correct to 2 decimal places. The first root is 1,71. The second one is 0,29. So we're going to clean the board, and then we'll go to the next question. Okay, the next question is solve for x. 113, x squared minus 2x minus 3 greater than 0. So the first things we're doing here, we're going to factorize, because this is a quadratic and inequality. We're going to try to get two numbers. The sum will be -2, and the product will be -3. So let's start with the product, 3 times 1. In order for us to get the sum of -2, so the negative sign will be on top of 3. -3 plus 1, we're getting -2. And -3 times 1, we're getting -3. So here our factorization will be x plus 1 times x minus 3. This will be greater than 0. So now here we need to study the sign in order for us to get the solution for this inequality. Yeah, this is the question. So we'll be having this table. Normally we can use this method of a parabola. Our parabola will be concave up because the sign of A is positive. So we can also use this way using the sign X. I need a little bit more space here. We'll be having X here. Here we're having X squared minus 2x minus 3. And the roots are, the critical value will be x is equal to -1. And the other one is x is equal to 3. So we'll start with -1. Here we are on the number line. And here we'll put 0, 0. Out of the critical value, we'll be having the sign of A. Remember, when we are having a quadratic equation, the standard form is ax squared plus bx plus c. The sign of A is plus, so we'll be having plus out, and in the middle it will be negative. Now, for our root, the inequality is this product of these two factors are greater than 0, meaning positive. So we'll be having here x is less than -1. The other side, x is greater than 3. So the solution here will be x is less than -1, or x will be greater than 3. This is the solution of the inequality. So if you want, there's another way of writing this. We're starting from negative infinity to -1, union from 3 going to positive infinity. That is another way of writing the solution. Then we're going to the next question, is 114. Here we are having exponential equation. 2 to the power of 2x minus 2 to the power of x plus 2 minus 32 is equal to 0. So we're going to split the exponent here. We'll be having 2 to the power of 2x minus 2 to the power of x times 2 to the power of 2 minus 32 is equal to 0. So here I'm going to pose like this, that y is equal to 2 to the power of x. And then here it will be y squared minus 4y minus 32 is equal to 0. We're having a quadratic equation here. We're going to solve for y, and then we'll come back here to this exponential form. Okay. We need to get two numbers here. The sum will be -4, and the product will be -32. 8 times 2. 8 times 2, we're getting, 8 times 4, we're getting 32. So our two numbers will be 8 times 4 Negative 8 plus 4, we're going to get negative 4. And negative 8 times 4, we're going to get negative 32. So our factorization will be y minus 8 times y plus 4 is equal to 0. And y will be equal to 8, or y will be equal to negative 4. And then we're going to come back to y is equal to 2 to the power of x. We will replace y by 2 to the power of x. It will be equal to 8, 8 being 2 to the power of 3. So the value of x here will be 3. For the other one here, 2 to the power of x is equal to negative 4. We cannot write negative 4 as the power of 2. So the only solution we are having here is x is equal to 3. Yeah, that was the question. For the other one, if we want to get a number, a 2 as the base to the power of x being equal to negative 4, we cannot find a number like that. So here we're going to write no solution. The only solution we're having is x is equal to 3. So we are done with this question, 113 and 114. We're going to go to the next question. We need space, so we're going to clean the board. Okay, so the last question under solve for x is this equation, the square root of negative 2x plus 4 minus x is equal to 2. So here we're going to isolate the square root, and then by squaring both sides, we're going to isolate the square root by doing this. Square root of negative 2x plus 4 will be equal to x plus 2. And then here we're going to square both sides. Here we will be having a negative 2x plus 4. It's going to be equal to x squared plus 4x plus 4. And then x squared plus 4x. This we're going to be transposed here. We're going to be having plus 2x minus 4 is equal to 0. Then we will get here. Let me see. Here is x squared plus 4x plus 4. Not 4x here. Not 4x here. X squared plus 4x plus 4 plus 2x minus 4. Then here we're going to get x squared plus 6x is equal to 0. We're having a quadratic equation here. We're going to factorize x. It will be x plus 6 is equal to 0. Then we are having a product equation here. X will be equal to 0, or x is equal to negative 6. So with these two roots, we must check if they're all verifying our equations. If we replace x by 0 here, we're going to get square root of 4 is 2. 2 minus 0, we're going to get 2. But if we replace x by negative 6 here, we will be having 12 plus 4 is 16. The square root of 16 is 4. And here is going to be plus 6. 4 plus 6 is 10. Is not equal to 2. Then here we're going to say x is equal to 0, or x different to 6, negative 6. The only solution we are going to consider here is x is equal to 6. So this was question 1, solve for x. We're going to go to the next question, and that will be 1, 2. As we are cleaning the board, we will go to the next question. Going to the next question, here is going to be 1, 2. Solve for x and y simultaneously. 2x plus y is equal to 3, and y squared plus xy is equal to 2. So here, we're going to solve simultaneously. We will say, let's consider this to be 1 and this is 2. From 1, we're going to take that y will be equal to 3 minus 2x. And then we're going to replace into 2. We're going to replace into 2. Into 2 here, we'll be having y, that is 3 minus 2x squared plus x multiplied by y again, 3 minus 2x, and this will be equal to 2. Yeah, that's the way the question is. It's equal to 2. Now, removing the bracket, squaring the first bracket, here we're going to have 9 minus 12x plus 4x squared. Here it's going to be plus 3x minus 2x squared. And this will be transposed. We're going to be minus 2 is equal to 0. Then we're getting here 2x squared. And here is going to be minus 9x minus 9x. 9 minus 2. Then we're getting plus 7 is equal to 0. So we are having a quadratic equation there. We're going to solve this by using this method of factorization or quadratic equations. So I'm going to use this method. We need to get two numbers. The sum will be negative 9 and the product will be 14. 7 times 2. For the sum to be negative 9, we will be having negative 7, negative 2. And when we multiply this, we're getting 14. So coming here, it will be 2x squared minus 7x minus 2x plus 7 is equal to 0. So here in the middle, minus 9x will be replaced by these two terms. And then we're going to group using GroupMe. 2x squared minus 7x minus 2x minus 7 is equal to 0. Here you must always pay attention. Once you are bringing the bracket here, the sign will change to negative here. And here we factorize x, 2x minus 7 minus 2x minus 7 is equal to 0. So we'll be having 2x minus 7 times x minus 1 is equal to 0. So the first root here will be 2x minus 7 is equal to 0. X will be 7 over 2. The other one, x is equal to 0. X is equal to 1. So we're having x is equal to 7 over 2, or x is equal to 1. So now we're going to come back. We're going to come back to here from 1. Y is equal to 3 minus 2x. We're going to replace these two values of x, and then we will get the value of y. Okay. X is equal to 7 over 2. Then y will be equal. We're going to replace here x by 7 over 2. So it will be 3 minus 7. So the value of y will be negative 4. If we replace here x by 7 over 2, 2 will be simplified. We'll remain with 3 minus 7, and y will be negative 4. And if x is equal to 1 for the next one, when we replace here, y will be 3 minus 2. we get 1. Yeah. This was question 1, 2. Solve for x and y simultaneously. We are done. I'm going to clean the board. Then we will go to the next question. Okay. So here is under question 1, question 1.3. Consider the product 1 plus 1 over 2 times 1 plus 1 over 3 times 1 plus 1 over 4 ... Each factor in the product is of the form 1 plus 1 over n, for n greater than or equal to 2. So here is the question. Determine all the values of n for which the product will be an integer value. So here we will start by writing our product. Product is equal. If I consider the first one, 2 times 1 is 2 plus 1, we'll be having 3 over 2. The next one is going to be 3 times 1, 3 plus 1, we get 4 over 3. 4 over 3. And if I'm going to continue here, we'll be having 5 over 4. We are multiplying. And if I reach getting the nth value, if we having n at the top, here the bottom one will be n minus 1. So here you're going to have n minus 1. And if I continue this product here, it will be having n plus 1, n minus 1 plus 1, we're going to get n here. So now, if I consider the factor which going to be before this one, here we're having n is going to be n minus 1 over n minus 1 minus 2. Down here is going to be n minus 2. If I want to write it. Yeah, so I'm going to write n minus 2. So I'm going to start by simplifying. Here we'll be having 3 by 3, 4 by 4. 5 is going to be with the next 5 which going to follow here. And here we'll be having n by n, n minus 1 by n minus 1. We'll be having here n minus 2. The factor which is going to be before n minus 1. This is going to be also simplified with the next one which is going to be here. So if we check the whole product, at the end here, we're going to remain with the n plus 1 over 2. All of these other factors will be simplified. We're only going to remain with n plus 1 over 2. So the question here, they're saying, determine all the values of n for which the product will be an integer value. For us to have an integer value, we're going to consider this product. The result is n plus 1 over 2. And here they say n must be greater than or equal to 2. So let's start with n is equal to 2. What is our product is going to be? Our product will be 2 plus 1 is going to be equal to 3 over 2. So our product will be 3 over 2. The product will be equal to 3 over 2. If n is equal to 3, here we'll be having 3 plus 1. We get 4 divided by 2. Our product here will be 2. 3 plus 1 is 4 over 2. We get 2. And if n is equal to 4, the product here, let me write the product, will be equal to 2. And here, The product will be, if n is equal to 4, 4 plus 1, 5 over 2. If I continue with n is equal to 5, the product will be 5 plus 1 is 6 over 2, then we get 3. As you can see, the product will be an integer. So, and this is going to be odd numbers because they say n is greater than or equal to 2. So we'll be starting with this one, 3. And if we continue our series replacing n by 6, 7, our n will be a member of this set. So it's going to be 3, 5, 7, ... Those will be the value of n. So n is an integer greater than 2, 3, 5, 7. We're having only odd numbers here, as you can see. So this is the answer for this question. All the values of n, here the values of n. We're done with this question. Then we're going to go to the next question. Okay, so here's question 2. 2.1. The first term of an arithmetic series is 7. The common difference of this series is 5, and the series contains 20 terms. First question, 2.1.1. Calculate the sum of this series. As you can see, we are dealing with an arithmetic series. We were having the first term, we're going to write, here is 2.1.1. The first term, T1, is equal to 7. The common difference, D, is equal to 5. And the series contains 20 terms, so our n will be equal to 20. In order for us to calculate the sum of this series, there are two formulas. I mean, one formula, we can have it in two forms. So before we get the formula, we first need to get the general term here. Tn will be equal to A, n minus 1 times D. So Tn will be equal to 7 plus n minus 1. And our common difference is 5. Yeah. So Tn will be equal to 7 plus 5n minus 5. Our general term will be 5n plus 2. We're going to need this for the next question when they are talking about the sigma notation. So, to calculate the sum of this series, there's a formula here. I'm going to write it down. Sum is equal to n over 2, a plus l. So if you check your formula sheet, there's this formula here. Sn is equal to n over 2 times a plus l. A being the first term and l being the last term. So here, the other formula, you can replace l by this Tn. You will have the other form of the sum. So the first term here is 7, n is 20, and the last term here, we need to get the last term. The last term here will be 20 because n is 20. T20 will be equal to 5 times 20, we get 100 plus 2, so it's going to be 102. So let's write the sum of the series this side. I'm going to clean the body on top, so we have a space here. The sum of the series, I'm going to write it here. The sum of the series, here is the formula. The formula is here. S20, it will be equal to 20 over 2. The first term is 7, and the last term is 102. Then we will take our calculator. 10 multiply by 109, then we get 1090. This is the sum of the series. Now we're going to go to the next question. I think here we are done here. This was for the first question. I'm going to go to the next question, 212. And I'm going to clean here because we need this space here. Yeah, so 212. The original arithmetic series is extended to 75 terms. The sum of these 75 terms is 14,400. Using sigma notation, write down an equation for the sum of the terms added to the original series. So we're having 20 first, and now we're going to go to 75. You can see the difference, how many terms we have added to get to 75. So the question is, using sigma notation, write down an equation for the sum of the terms. So remember, we got our general term, because if we want to use sigma notation, we will need the general term. It was 5n plus 2. Here they are saying the original arithmetic series is extended to 75 terms. The sum of these 75 terms, S75, is given, is 14,400. If we want to write down the equation of the sum, the terms added is going to be, let me clean the board here so that I can come back here. Now let's continue here. So we're going to have S75 minus S20. Then we will get the sum of the terms added. This one, we know it is given, and this one also is given. So what are we going to have here? We'll be having 14,400 minus 1,090. Let's get our calculator. So we'll be having, let me write it down here so you're going to be easy. 14,400 minus 1,090. How much are we going to get there? Minus, then we get 13,310. So now we must write this using sigma notation. I'm going to write it down in sigma notation. The first one is going to be S75, sigma notation. It will be like this. And starting from 1 to 75. And here is our general term, 5n plus 2. And here is going to be minus the sum notation, sigma notation for the next one. And sorry, here it's the general term always. Here is going to be 5n plus 2. Then we're getting 14,400 minus 1,090. And we end up getting 13,310. So therefore, if I want to write it considering an equation of the sum of the terms added, this is the word. So here will be our final answer. Therefore, we'll be having the sum n starting from 21 and n going to 75, we have 5n plus 2. This will be equal to 13,310. Here's the explanation, and our final answer is there. Here it was for the first 75, the first 20, and when we get the difference, we're getting 13,310. Here's the sigma notation we really need to get for this sum. So here we're done with question 211 and 212. I'm gonna write down the next question. So yes, we are done with this one. Okay, so here's under question 222. The sequence of the first differences of a quadratic pattern is 135. 221. If T99 of this quadratic pattern is 9,632, calculate the value of T98. Question 222. If it is further given that the third term of the quadratic pattern is 32, determine the general term, Tn of the quadratic pattern. So we're going to start with question 221. If T99 of this quadratic pattern is given 9,632, calculate the value of T98. So here is 221. If we consider this first difference, 1, 3, 5, the next one will be 7, and so on. So let's get the general term of the first differences. Tn will be, the first term is 1, n minus 1, and the common difference here is going to be 2. So Tn will be equal to 1, 2n minus 2, and Tn will be equal to 2n minus 1. So this is the general term of the first differences of the quadratic pattern. So the first question here, they say, if T99 of this quadratic pattern is given, T99 is given 9,632. So they want us to get T98. So for us to get T98, we will need to get the 98. We need to get the 98 first difference. 98 first difference. And what is it going to be? We will replace n by 98 here. So it's going to be 2 times 98 minus 1, because the first differences are given by this general term, 2n minus 1. So we're going to calculate the 98 first difference. It's going to be 2 times 98 minus 1. Using our calculator, what are we going to get? 2 multiplied by 98 minus 1. We're getting 195. 195. So now it's going to be easy for us to calculate T98. So T98 will be equal to T99, 9,632 minus 195. This is the 98th first difference, 195. So we'll be taking T99 minus the 98th first difference, and then we're going to get T98. So let's do the calculation. 9632 minus 195 we're getting 9,437. 9,437. This is T98. So we have responded to the question 2 to 1. T98 is here. We're going to need a space for this question 2 to 2. And for this, I'm going to clean the board and the top here for us to be able to take this question. All right. Yeah, I think so. Or maybe let me start down here. If we're still going to need space, then I'll clean the body. I can clean the body here because, by the way, we are done with this question 2 to 1. So, you remember when they are saying first difference, it means it's going to be like this. Here we'll be having 1, 3, 5, and 7. Now, here they are saying, if it is further given that the third term of the quadratic pattern is 32, meaning 1, 2, 3, here is going to be 32. So it's easy, we can get the previous terms. 32 minus 3, we're getting 29 here. This is going to be the second term. 29 minus 1, then we're getting 28. Yeah, so here's the first difference. If we want to get the second difference, it's going to be like this. Then we'll get 2 here. 2. Yeah. So the question here is to get the general term of this quadratic. General term, remember, Tn is equal to an squared plus bn plus c. We need to get these three constants, a, b, c. The first one, remember, if you know the second difference, you can get the first coefficient, the value of a. So we know that 2a will be equal to 2. The value of a is 1. Now, if we replace n by 1, we'll be having T1 is equal to a plus b plus c. Yeah, so let me clean this top one so that I can explain in details so that you can understand how we're getting this. So here's what we're getting here. T1 will be equal to a plus b plus c. T2 will be equal to 4a plus 2b plus c. And T3 will be equal to 9a plus 3b, 3b plus c. If now I take T2 minus T1, we're going to get 3a plus b. 3a plus b, 3a plus b. T2 minus T1, we're getting 3a plus b. T2 minus T1, here we're going to have 29 minus 28. And then we're getting 1a. We know already that a is 1, so it will be 3 plus b is equal to 1. And the value of b will be 1 minus 3. Then we get minus 2. We know a We know B. Now we need to get the value of C. Yeah. A is 1, B is -2. We need to get the value of C. To get the value of C, we're going to consider T3, because T3 is given. They were saying here, the third term of the quadratic pattern is 32 here. So we'll be having here 9A plus 3B plus C is equal to 32. Yeah, that's what the value which was given in the question, 32. Now, let's replace A and B so that we can be able to get the value of C. A is 1, 9, and B is -2. So here we're going to be -6 plus C is equal to 32. Here we'll be having 3 plus C is equal to 32. And the value of C will be 32 minus 3. We're getting 29. And finally, our general term Tn will be equal to A1 n squared plus B, the value of B is 2n plus C 29. So here's our general term, n squared minus 2n plus 29. We are done. We have covered question 2.2. So we're gonna stop here, and then we will continue with the next question. If I check very well here, this was practically question 2, then we will go to question 3.